Hello everyone. So this is the first lab, which is the beginner lab for GitHub Actions and GCP connections, how to configure the GCP and GitHub Actions to interact with each other. And what I'm aiming to do in this video is that I prepared a very detailed and a step-by-step README file. So please do read this, and I think that's enough for following along this lab. But what I'm going to do, I'm going also to follow along these instructions myself step by step to see if everything is working perfectly, so you have also a better idea. So the learning objective of this lab is to learn how to set up a GCP project and configure a service account for that project. We will need that service account for the GitHub Actions. And then we will learn how to give GitHub Actions access to the GCP project. We learn how to automate the process of training a model and saving the model on using the GitHub Actions, and so forth. So okay, let's go through it. Okay, the first step is that you need to create a new repository. So okay, I'm going to do this. My GitHub. I'm going to create a new repository. I just give it a name, GCP 2, for example, something like that. And public or private, it's your preference, and you don't need to add any README, you don't need to add any .git ignore. Go ahead and create the repository. Now we created the repository. This link is important for us. We are going to use it later. But for now, let's go through the rest of the steps. So we are done with step 1. We go to step 2. Now we need to clone the main project that's been provided for you for this lab. And so you need to clone it. Then you need to change the directory to that. And then we go through the other steps. So let me clone that. What I'm going to do, I'm going to copy this link. And then I'm going to clone this project here. We cloned it here, and then I'm going to change the directory into that project. Yes. Now let me just show you a list of the things that's here. There is a git ignore file, there is a readme file, there is a requirements, and that's the main Python script for training and saving the model. And we also have a .git file, which is a record of all the Git tracks of this project. So we go through the rest of the steps in the instruction. Now what we need to do is to remove this .git. And the reason of this is that because you cloned this project from a already GitHub project and repository, but you want to link this project to the new repository that we created here. So we need to get rid of this previous repository. And this is how we do it. We just say rm rf.git. We just remove the directory of the Git files. And now we just prove it one more time. That's removed. Yes, it is removed. That .git is removed now. Perfect. Now we go through the other steps. Now we need to initialize a new GitHub project in the directory. And I'm just following along the steps. Git init, and it's initialized. Now we add and commit all these files into this Git project, and we say git add dot. That's it. And now we commit initial commit just with a random message. Now the rest of the steps we did this. Now you need to link that local GitHub project and repository to a remote GitHub repository, this new GitHub repository that we created. And this is how you do it. Git remote, add origin, and the link that's here that you got when you created that. So I'm going to copy this link. Then I'm going here and I'm going to say git remote add origin and paste that link here. Great, now we linked it, Now let me just open from now on Visual Studio Code so we feel more comfortable working with this. Yes, awesome. We have it here. Let me also open a terminal for this project. Great. Now let me go through the steps, other steps. Now we need to push the local files that we downloaded from the previous repository, and I'm just going to copy this command here, and I'm going to paste it here, and I'm going to push it. And now we pushed it here in this new repository that you created. If we refresh the page, we need to see these files. Great, and we are seeing all of the files here. This Python script to train and save the model. And let me just remove this, and we go through the next step. So we are done with the step 2. Now we go through step 3. Step 3 is creating a virtual environment. We create the virtual environment by this command. Let me just go here. We say Python 3. So because I'm on Mac, it doesn't matter actually. Let me just go ahead with the same thing that we and as you can see, a new virtual environment is created here. We remove this and we activate this. I'm just gonna copy this command here, and it's activated now. And what we need to do now, we need to install the dependencies. I'm gonna copy this command here, paste it, and as you can see, the dependencies are being installed now. We wait for a couple of seconds. So that's just this, ignore this error, it's about the version of the pip. Now what we need to do, we go through the next step, and the next step is to set up a Google Cloud Platform. So we need first to create a project, a new project in the Google Cloud Console. So I'm going to go to the Google Cloud Console. This is the console, and we go to this account. So I'm not going to use that account, and what I'm going to do, we go here and we click new project, and we just name it GitHub Actions GCP, and I just give it a name 2, for example. Then I hit create, and then we wait for it to be created, this project. It takes some time. Now it's created, we select it as the default project, and as you can see, this project has been chosen, the new project that we chose. You need to be on this project and to be able to follow along the next steps. What we need to do now in the next step is to create a service account and give it the required roles and permissions to interact with the Google Cloud Storage and other stuff. So what we do here, we need to create a service account. So I'm gonna go to I am an admin, and you go here by clicking here. You are in this dashboard. On the left side here, you need to find the service accounts, and here, as you can see, service accounts are here. Choose it. There is no service account because this is a new project. We say create new service account. Now we just give it a name. I call it GitHub Actions GCP SA, just the name. You can choose any name you like, and then we say create and continue. Now it says what roles we are going to give it, and because we want to give this service account the permission to interact with the Google Cloud Storage and buckets, we need to give it the storage admin role, storage admin, so it grants full control of buckets and objects. We choose this, and we say that's the only role that for this project that's required, and we choose continue. Awesome, I think everything is set. We don't need to change anything else, and we say done. And as you can see, the service account is created and it is enabled. Now we look at the other steps that we need to do. Oh, and we need to generate a JSON key for a service account and save it somewhere. So here you choose that service account that you created. You go to the keys tab and you say add key. We need to create a new key, and we want it to be a JSON file, and we hit create. And once you do this, it downloads to the folder here. So it's going to be here, so I'm going to use it later. We don't have anything to do with this right now, we don't need it. So now we go through the rest of the steps. So we also completed the step 4 for the Google Cloud Platform. Now step 5 says create a Google Cloud Storage bucket. So we go to this console here again, and we say storage, cloud storage buckets. So again, on this project I say create. This is how we create a new bucket, and just pay attention that the name for this bucket needs to be globally unique, otherwise it's Google Cloud is not going to accept it. So what I'm going to give it a name, I'm going to say GitHub Actions GCP and models, for example, and then I just also give it also number, just a random number. I say continue. So okay, that name hasn't been chosen previously. So here the region, it doesn't matter if you go with the multi-region or dual regional region. I'm gonna go with the region because it's just cheaper. And we say continue, and we leave the other settings as they are, as the standard. Say continue, and we say continue, and we say create, and it says prevent it from the public access, which is what we want, and we say confirm. And now the bucket is created, and the name of it is GitHub Actions GCP Models 2, as you can see, just a random name. Now we go to the steps here. So it says navigate to the storage and select the buckets. We did that. Create a new bucket script. So now we go to step 6. Step 5, which was the creating the bucket, is also done. Now step 6 says upload the service account JSON key to GitHub Actions secrets. Okay, this is a very important step, so please pay attention carefully. So where we are here is in that GitHub repository that we created, and you also created that new GitHub repository. What you need to do, this is how GitHub Actions recognizes the keys and secrets and these sort of things. You need to go to the secrets. You go to the settings of that repository, then you go to secrets and variables, you choose actions because we want to give the GitHub Actions the permission, and here we choose the new repository secret, and I just give it a name. The name of that is up to you, but I'm choosing it as GCP service account key. And in this secret value, what you need to do is to copy and paste the context of that JSON key file that you downloaded previously from the GitHub, from the Google Cloud. So I'm going to find that folder very quickly here, and I am going to open it with a text editor, and I'm gonna copy and paste it. And this is a secret actually key. It shouldn't be exposed to the public, and because right now at the time that I'm recording this video, after I'm done with recording this video, I'm going to go ahead and remove everything. I'm going to remove the service account, I'm going to remove the project. So that's why I'm letting you see all of this, otherwise it shouldn't be the case. Now I copied this, I paste the content of that JSON key here. Now we say add secret, and as you can see now we have a new GitHub Actions secret, GCP SA key. So I think we are also, yes, we are done with step 6 successfully. Now we go to a step 7, which is the main step, the set up the GitHub Actions workflow. Now let me just walk you through all the things that they are in the project, as we can see. Okay, so we go to GitHub and workflow, and there is a new workflow that's been that I wrote for this project here. The name of this workflow is train and save model to GCS, and as you can see here, I put it to be triggered, this workflow to be a schedule at every day at midnight. So this is just an example. So let's say you have a project and you want your model to be retrained every night, or maybe once a week, or whenever you push something new to your repository, this is how you do it. And this workflow dispatch is just to make us be able to also run the workflow through the GitHub repository, so we can check it also there. The only job that this workflow has is just train and save. So the first step that we are doing, so we are choosing an Ubuntu latest machine from the GitHub remote machines, and the first step is to just check out the code. So what we are doing is just copy and pasting all this code into that machine that we are borrowing from the GitHub. And then we set up a Python environment, because this is a Python project and we need to install the Python. So we use an actions for this, and the actions is set up Python. I'm using the version 5, which is the latest version at the time of recording this video. And I choose the Python version. There is a parameter for these actions, Python version 3.10, and I'm choosing it 3.10. And now this step is choosing to just choose the directory of where pip saves all the installed dependencies. What we are aiming by doing this is just get the name of that directory. So what I'm doing is just run the command of we put the key value of dir installed equal to pip cache and dir, and this is the command that pip gives us that the name of that directory that they save the dependencies, and then we save it into the GitHub output environment parameter. This dir key value here, we are going to use it later. Now in the next step, what we are doing is that because we don't want every time and every night, let's say, that our model is going to be retrained, so our machine is going to install the dependencies again and again and again. If nothing has changed in the requirements, we want to give that machine to use the same dependencies and just cache these dependencies. So there is a actions for this. They call it actions cache version 4. And now you need to give a path where that we got where pip caches the dependencies, and this is where we use this key and value pair, and steps.pip cache there, and you just need to copy paste this. And the key here, the key parameter here is important, because we want also to let GitHub know that each time we change anything even minor in the requirements.txt file, we want the dependencies again get reinstalled in a fresh way. So we don't want it to use those previous installments, because that would cause some error and it will throw some error. So we are just giving a unique key, and the name of that unique key is runner.os, the machine, the OS, the operating system that this machine is being running on. So in this case is Ubuntu, Linux, and then a pip, and then we use hash files, and then we give the path of that requirement. So what happens is that if each time this requirements.txt changes, this will get a new hash file, and if this doesn't change, this hash file doesn't change, and then the GitHub machine can access those previous dependencies and just go over this pip install step. The next step is to install the dependencies. We are upgrading the pip, and then we are installing the dependencies with this command, which we've seen it previously. Now the next step is we need to authenticate with GCP, and again we use actions for this. There is an action which is Google GitHub Actions and authentication version 2. You need to give this parameter credentials JSON, this secrets.gcp SA key. So this name is the name of, let me just show you really quick, the name of this secret that you added previously to this repository secret, GCP SA key. And we go here and we are saying that for the credentials you can use that JSON file that I already gave to GitHub, and this is how you do it in GitHub. It's an environment variable, secrets.gcp SA key. Now we are going to authenticate with GCP to make the GitHub Actions be able to interact with GCP. Now the last step, which is train and save the model. So this is the script we are going to run. We are going to say run it, train and save the model. Let me just open this file one time So you can see it. So this Python script is actually a very simple. The first is just we import the libraries that we need for running this project. We are importing the train test split and random forest classifier and accuracy score, and we are also importing the storage library from the Google Cloud and other libraries. So first we download the sample dataset. We are using the iris dataset from the scaler. And then it returns the features and target. Then I defined a new, a very simple pre-processed data, which is just splitting the dataset into train and test, and this returns xtrain, xtest, and ytrain and ytest. Now this is a model that trains the model. If we pass it the xtrain and ytrain, and it returns the model. Again, very simple and basic, because that's not the focus of this lab. Now this is the important part, which is we need to define a function to save the model in GCS. How we do it is this: we create a storage client, storage.client, then we create a bucket object, a storage client.bucket, and we will give the bucket name. This function gets the bucket name as a parameter, and then we define a blob object, and then we say that blob upload from the file name, and this file name is that model and model job lib that we trained previously. Now in this main function we put everything, and we connect all these functions together. First we download the data, then we pre-process the data, then we train our model. This will return a model object. Then we just evaluate a model, which is just something really basic. Now here, this is important. For following along this lab, you need to change this bucket name in this Python script to what bucket name that you have chosen before. For example, here, I need to change it to the new bucket name that I've chosen. So what I do here is I go to this Google Cloud Console. Now here I copy paste the name of the bucket from here or somewhere else, and I go here and I paste that name here. I hope it's correct. Yes, it's correct. Now we are just giving a timestamp at the time that the model has been trained and this script has been run. Then the name of the blob name, which is the name of the folder on the bucket, is train models, and the name of the model, and then timestamp. Then we use that save model to GCS to save the model, and it just gives us a confirmation also at the end. Now we changed all of this. Now what we want to see, if this is working fine. Now we are on this terminal, and what I'm going to do, because I changed something, I'm gonna push this. Let me just updated name of the bucket, for example, and now you push this. We pushed it successfully. Let me just check here. Yes, this is our repository here. Let me just check that we haven't missed any step here. Yeah, this is I'm also explaining all the steps here. So what we need to see here, when we run the action, we go to the action section, train and save model workflow to GCS here. This is there, and let me just run this manually for now to see how it works. For example, this is run the workflow. I'm manually triggering the workflow. Let's see if everything works fine or not. It takes some time here to show it. Yes, now the workflow has been run. As you can see, the dependencies is being installed right now. This is how you can see the messages of the GitHub Actions. Let me just close this. Take some time. And the authentication with the GCP also was successful, and this is also caching, and let's wait for the last confirmation. Yes, as you can see now, it's the GitHub action workflow has been triggered successfully. So let's see if we can see the save model on the Google Cloud bucket and the name of that folder. Yes, as you can see in this bucket, we can see the train models folder, and that's the model that's been saved. As you can see, it's the name that we gave to it, model, and the date that we run this, which is the September 17th, and the hour and seconds and minutes. So this is working fine. And one more last thing that I want to show it to you is that right now, let me just go to the code here. Right now the workflow here is just we set it to be triggered at 12 every night, and also manually. Let me just change this to also make it able to retrain the model whenever we push something new to the main branch of this repository. So let me just go here, we go in here, schedule, and we just say push and branches main. This is how we do it, and I save this now because we've changed something. Let me just, now we have changed something, let me just commit these changes, git commit, in a message, updated workflow to trigger on push to main branch. Now let me push it to the remote repo. We'll push it. So once we reload, let me reload this page and then go to this repository. We need to see it. Yes, it automatically has been triggered again retraining the model because we push something to the main branch now. And I think this is going to also work fine. And let me just show you something really actually useful here, that cache pip dependencies step. As you can see, it says cache restore successfully. So this is where it is useful because it's not taking much time, you know, like these dependencies, you know, like it's just restoring the previous file, and this key file that we gave it, like Linux runner.os, that pip, and that hash key that's been generated based on the requirements.txt. Yes, everything is working fine. Let's see if we see the new models in our bucket too. Yes, and the second model is also here too. Yes. So I hope you find this lab useful, and thank you very much.